Hello，大家好。今天呢，我又带了3个题上来，那么感兴趣的同学呢，也可以试一下。我觉得呢，今天的Extension 2的题，就是复议的那个题，我想大部分的同学都会觉得有问题的。Let's have a look. Okay, let's start the first question. First question is a log 4, 1, 2, then equal to log 1 on root 2 over log 4, then equal to, so this is a log, this is the 2 power minus half. Bottom is the log, this is the 4 is the 2 power 2. Then equal to, this power, I can move to front. So this minus is the half, times is the log, this is 2. Then this the power 2, I can move to front. Will be 2, this is the log, this is the 2. Okay, log 2 cancel, will be equal to minus 1 on 4. Okay, we finished the first question. Then we're looking at the second question. So second question is given sine x is larger than 0. Then differentiate the y equal to sine inverse cosine x, simplifying your answer fully. Okay. So now after the theta y, theta dash. Differentiate is y dash equal to, so the this will be 1, theta sine the inverse to the differentiate will be equal to 1 minus the this part square. Then time the cosine x to the differentiate, cosine x to the derivative, so will be give you minus sine x. Okay, then equal to 1 on this one is the sine square x times this is the minus is sine x. Okay, then equal to, so they given the sine x larger than 0. So the this part will be equal to theta 1, just a sine theta x. Then times the theta minus sine theta x. Okay, then equal to sine theta x divided sine x is a minus, so minus 1. Okay, this one means the gradient will be always equal to minus 1. Okay, now we look at the next question. Okay, this question, the first one. So using this diagram to find the value of the A, B, and C. Okay, the first one you can see at this point. At this point, so x equal to 0, so y equal to 0. Okay, I just sub the theta, make the theta x equal to theta 0. So theta f, the theta 0. So equal to theta a times the theta 0 plus the theta b times the theta 0. Then plus the c. Because we know that when x equal to 0, so since the y value is 0, so the c must be equal to theta 0. Then we know c must be equal to theta 0. Okay, I write the theta fx again. This is the fx will be equal to this the ax squared plus this the bx. C is 0, I don't want. Then I want to find the excess of symmetry. So I found the excess of symmetry. So x will be equal to minus the cis digit minus the b on theta 2a. So excess of symmetry will be always equal to this x front digit divided this x squared front digit and then put a minus. This time excess of symmetry, we already know the x equal to 2. So I make the this equal to theta 2. Yeah, because the excess of symmetry, you can see that this one's where x equal to 2. Okay, so now from the here I can see, so b is must equal to minus theta 4a. Okay, so now I write this fx again. So this fx will be equal to this ax squared plus bx. Bx is the minus the 4a. Okay, I got this one. Then I subtract this point. This I subtract this vertex here. This maximum point when x equal to 2. This y value is the 4 on 3. Okay, I subtract this point to the this function. So theta 4 on theta 3 equal to theta a when x equal to 2. Minus theta 4 times a times the this x are using 2 to replace. Okay, so now theta 4 on theta 3 then will be equal to theta 4 theta a minus theta 8 theta a. Then theta 4 on theta 3 then equal to minus 4a. Okay, so now the a must be equal to okay, so I found the a. Okay, then I found the b. Okay, then see the b will be equal to here minus 4a minus theta 4a then equal to theta minus 4 times the theta minus 1 on theta 3. Then this will be equal to theta 4 on 3. Okay, so we already found that a equal to minus theta 1 on theta 3. Then theta b equal to 4 on 3. And theta c is equal to 0. Okay, so now I just write this fx again. Okay, I write this fx again. So fx, so far, so we got the fx will be equal to ax squared. So fx will be equal to ax squared. A is a minus is 1 on theta 3. Then theta x squared. Then this is minus is 4 times a will be plus 4 on 3 because b is 4 on 3 plus bx means 4 on theta 3 theta x here. Okay, now this function so coming to minus 1 on 3x squared plus 4 on 3x here. Okay, we do the first part already. Okay, so now we do the second part here. Second part is solving fx. So between less equal to 1 and the large equal to minus 1 and less equal to 1. Okay, we try to solve now. Where's the fx minus 1? So fx minus 1 is the minus 1. For example, I just put this one. It's a minus 1. So they want the fx can be between minus 1 and a positive 1. So positive 1, I just can put this one. I just say positive 1 here. Okay, that means I need to find this minus 1, this one, the x value is here. Then positive 1, the x value is here. So we need to find the this point and this point here. Okay, so I just make the fx. I'm just using the minus 1 to replace here. So theta minus theta 1 on theta 3, theta x squared, plus the theta 4 on the theta 3 theta x, then equal to minus 1. Okay, so another minus 1 must be here. Another minus 1 is here. Okay, I need to find this one as well. Okay, so now for this one, then I just alternate time the minus 3. So I will get theta x theta squared minus theta 4x, then equal to, if alternate times minus 3, and then this becomes the positive 3. That means this is x squared minus theta 4x minus theta 3, then equal to theta 0. Okay, find the x. So the theta x will be equal to, using quadratic formula, theta 2, so theta 4. Theta plus the minus, this one is the 4 squared, 16, minus 4ac means the plus theta 12. Okay, then equal to, this will be give me theta 2, theta 4, plus minus theta 2, 28, 28 is 2 root 7. Okay, so theta x will be equal to, I simplify with theta 2 plus minus theta root 7. It's around 2 plus theta root 7 is 4.65. 4.65. So another one will be theta 2 minus root 7 will be minus 0.65. Okay, so what this means here? So this point, the x value we already found. The x value is a minus the 0.65. So another minus 1, this value is the 4.65. Okay, this value will be the 4.65. Okay, now I only do this part. I also have to do this part here. Then I just make the fx equal to 1. Okay, I make this fx. So this minus theta 1 theta 3 theta x squared plus the theta 4 on 3 theta x equal to 1. I solved this equation here. So I just alternate times 3 will be minus theta x squared plus the theta 4x, then equal to theta 3. I just move everything to the right hand side. So this will be give me the x squared minus theta 4x plus theta 3 equal to 0. And this one I can factorize. So theta x is a minus theta 1. So the theta x is a minus theta 3, then equal to theta 0. Okay, so theta x will be equal to 1 and 3. What does this mean to you? So when x is 1, this value x is 1 here. Then another 1 is here. Another value y equal to 1 is the when x equal to theta 3 here. Okay, so now, they want me solve the fx large equal to minus 1 and then less equal to 1. Okay, I can just write. So this is the final answer I will write. So theta x will be less equal to theta 1. Then large equal to theta minus theta 0.65. Another one, okay, so theta x will be less equal to 4.65. Then large equal to 3. Okay, have a look. Then when x is minus between the minus 0.65 to 1. So which part? So okay, x between the minus 0.65 to 1. This part you can see when you go to this part means the y value is from the minus 1 to 1. So another one where x is between 3 and 4.65. Means this y is between minus 1 to 1. So when fx between minus 1 and 1, we can go to theta 2 interval. So one interval is the x between minus 0.65 to 1. Another interval is here. It's between theta 3 to 4.65. Okay, so we already got the theta 2 interval. Then we do the next part here. It's very long, this question. Okay, so now the question 3, so require, so hence or otherwise sketch the y equal to log fx. Okay, first one, I just draw this one. Okay. So we got the theta fx. So the fx then equal to theta minus theta 1 on theta 3 plus x squared plus the theta 4 on theta 3, theta x here. Okay, you can see that this curve, okay, this curve is here. The logarithm, this part has to be the larger than 0, even not equal to 0. Cannot equal to 0. Only the positive part, we can draw the theta log here. Okay, so what does this mean to you here? Okay, so I just okay, so now theta original curve is goes this. So original curve is Z is here. Theta 0, theta 4, and this maximum point is 4 on 3. Okay, when I draw theta y equal to theta log theta fx. Okay, so when I draw this one, I have to take off this one, not include this one, not include this one. Only positive side we can draw because the log, the this part will be always larger than 0. Okay, so now I just draw the theta y equal to log x here. So log the 4 on 3. So log the this 4 over this 3, then equal to, okay, maximum point is the 0.28, 0.29. If this is the 1, then this is the 2 here. When x equal to the 2, then see the log, this one is the 4 on 3. 4 on 3, then I just check that this will be 0.29. Okay, so maximum point will be set at 0.29 here. Then you can see that this part, small, getting small, eventually coming to the 0. For the logarithm, if this number is very small, for example, you can use your calculator to type the log 0.00001. This will be give you the very big, the negative number. So we'll be giving this a very big, the negative theta number here. Then another one, the same. Yes, this part you can see this number getting smaller. If this number very small, you can just try to sub log the 0.00001, and this number also give you the very big, the negative number. Okay, so I already finished the first curve sketching. First one, curve sketching, I already drew this one here. First one, I want to draw this one. Okay, I just say one more time. So only this when fx positive side we can use. Then see the negative part we have to take away because the log can't put the theta negative here. So when I got this one, theta 4 on 3 is fx the maximum. I just put the 4 on 3 to here. I got this number is the 0.297. So when x equal to 2, this point be 0.239 here. Then you can see approaching to here. So fx getting very small. Very small the number you replace here. And this number y will be given the negative number, but very big the negative number. So continue will be go this way. Then this is the same. So you can see this is getting smaller here. So you just using the very small, the positive number is up here. Will be giving very big the negative number. So I already draw, go down. Will be very big the negative number. Okay. The first one I already draw. Okay, now I draw the next one. Next one is draw this one. The second one, B. So want to us to draw the y equal to theta cosine, theta inverse. Theta f, the theta x. Okay, So I just draw the system one more time again. So original curve is go here. Okay, so we know, so the c is minus 1. If the c is minus 1, see the x value. 6.x value is the minus 0.65. And we also know, so when y value is a positive 1, the x value is the 1. Then we also got the this one, where the y value is 1. So y value is 1, so the x value is the 3, is the 4. Then 4.65. So when x is 4.65, see the y value is the minus 1 here. See the 1, see the minus 1. And this is the 1 and see the minus 1 here. Okay, we can draw the cosine inverse curve. Cosine theta inverse curve is, okay, so when theta x is equal to theta minus 0.65, so the theta value will be equal to minus 1. Cosine inverse minus 1 will be give you pi. So I have to do this point here. Okay, so now when x equal to positive 1, the y, so y value is a positive 1. See the 1 here. Cosine inverse 1 is 0. So we got to this point here. Then we can just draw it. Okay, another side. When x equal to 3, so since the fx is 1, since the value is 1, cosine the inverse 1 is theta 0. I'll put theta 2, then theta 4. Okay, theta 2, theta 3, and this is theta 4. Then theta 4.6 somewhere here. Theta 4.665. Okay, so when x equal to 4.65, and this time fx value will be have theta minus 1 here. What is cosine inverse minus 1? This is the spatial angle is pi. So it means that when x equal to 4.65, so the theta y value will be have theta pi here. Okay. Okay, so now we can just draw this one. Okay, so I can draw this again. This is it. Okay, so now I finished this question here.